We are now up to Chapter 6, Lesson 7, Graph Linear Inequalities with Two Variables. So we're going to combine our understanding of how to graph lines and also how to represent inequalities. So let's look at this quickly. A linear inequality is in two variables such as x minus 3y is less than 6 as a result of replacing the inequality symbol with an equal sign. So basically, what you're doing is, so in this case here, what we're actually going to do is we're going to replace the inequality symbol with that equal sign, and that's going to graph our line, and then we're going to determine which side the set of solutions are on. So let's look at this now here. Which point is not a solution of x plus 2y is greater than or equal to 7. So what we're going to do is we're going to plug in the x coordinate, which in this case is, first one is -1, plus 2 times 4, which is going to be 8, because I'm plugging it into this equation, or this inequality right there. And is that greater than or equal to 7? That's for this one right here. Yes, this is going to be 7 is greater than or equal to 7, so it is a solution. So now we're going to do the same thing for this one here. So I plug in 2 plus, and again, all I'm doing is I'm plugging them into this inequality. 2 plus 2 times 4. Is that greater than or equal to 7? Yes, that's 2 plus 8. It's greater than or equal to 7, so 10. Yes, that's true. So, so this one is a solution, this one is a solution. So now let's try 11 and -2. So is 11 plus 2 times -2, is that going to be greater than or equal to 7? Let's see. 11, 2 times -2 is going to be 11 minus 4. Is that going to be greater than or equal to 7? Yes, it is, because this is going to be 7 is greater than or equal to 7. So this is also a solution. So that last one I'm guessing is not the solution. So let's see here at the bottom here. It's going to be x. So that's 8 plus 2 times -1. Is that greater than or equal to 7? Well, this is going to be 8 plus -2. Is that greater than or equal to 7? No, it's not. So this is going to, because this is going to be 6. So this is the only one that is not a solution. So that's how you do that. So that's how you do this sort of problem. And again, you're just plugging in these numbers and seeing if it's a solution. So I plug in 0 here for the x and 0 for the y. Is 0 less than 8? Yes, it is. So this is a solution. I plug in 0 for this one here, 0 for x and 4 for y, and that would be 0 plus 8, because 2 times 4 is 8, so this is not a solution. And for this one here, I'm going to plug in -3. This one here I'm actually going to write out because I have more, I have to plug in something that's not 0 for the x, plus 2 times 5. Is that less than 8? So let's see if that's true. This is going to be -3 plus 8. Is that less than 8? Yes, that's true. So that is a solution. So that's how you solve these. They can get a little bit more complex, but it's the same concept. We're going to move on to the more challenging part, which is the graphing inequality parts, and then figuring out the solution. So the way this works is that if you're given an inequality and asked to graph it, like this one here, 3x minus y is less than or equal to 1. So that's our inequality. First thing you're going to do is change it into an equation. So the equation is going to be 3x minus y is equal to 1. And you can do this however you want in terms of graphing. I would probably just use y-intercepts, and all I would do is I'd say, well, what's the value when x is 0? What's y's value going to be? So it's going to be 3 times 0 minus y is equal to 1. So y is going to be equal to -1, because negative 1 is going to be 1. So that's going to be my point right there. And then I would go ahead and plug in 0 for y. And when y is 0, then x is going to be, then the equation is just going to be 3x is equal to 1. So x is going to be equal to 1/3. And so it's going to be 1/3 for x. So you can kind of see it would just be right there. Then you connect the dots. And because it is this type, it is a solid line. It is not a dashed line. So the next step is, what you do is you test and you see. Most of the time you'll be able to use 0, 0 as your point to test, because 0, 0 is not a part of the line. So what you're going to do is you're going to see, is this part a solution or is this part a solution? So I'm going to test this by plugging in 0, 0. When I do that, 3, that's what it says here, 3 times 0 minus 0, is that less than or equal to 1? Well, is that a true statement? Well, it's 0 minus 0 is less than or equal to 1. So yeah, that is a true statement. So that means that the part that I need to actually color in to indicate it's true is just the red part. The blue part was not accurate. So that's the reason why I would go ahead and color in that. And that's how you indicate that that's the whole solution to the inequality. Let's try another one here. So here I've got the inequality, let's see here, the inequality x plus y is greater than or equal to -2. This one here is pretty easy to figure out the line, because all I'm going to do is I'm going to change it into an equation. And then it's just, well, figure out it based on intercepts. When x is 0, y has to be -2. And when y is 0, x has to be -2. So -2, 0, that's going to be there. It's going to be right there. And 0, -2 is going to be right there. So all I would do is I'm going to try and connect the dots nice and neatly, but I may not do it great. It's going to be a filled in line because it has this type of symbol. And now what I'm going to do is I'm going to check and see whether or not I need to color in the part that has the origin on it, 0, 0. So all I'm going to do is I'm going to plug in test for point 0, 0 into this original inequality. So is 0 plus 0 greater than or equal to -2? Is that a true statement? 0 plus 0 is 0. 0 is greater than or equal to -2. That means I shade in all of this part here, because that is a true statement. So I've got to have that one point. And again, the key thing that I think is sometimes is hard to understand is this, that if this one point is a solution, then everything on this side of the line is a solution. If one point on this side was a solution, then everything on this side was a solution. But that's not the case. It's just the red side that is a solution in this case. So let's try another one here. This video might go a little bit longer simply because this is kind of a complex concept. So this is the new equation. And I'm just going to change it into an inequality, or the new inequality, I'm going to change it into an equation. So now, if I want to do it using intercepts, I can still do that. When x is 0, what's y going to be? It's going to be -2 is equal to 6. So y is going to be equal to -3. Okay, so that's the first point. The second point is going to be, if I want to do this, it's a little bit harder to see, or a little bit harder to read, but if I plug in 5x and the y is 0, and it's just going to be 5x is equal to 6. And again, I'm just plugging it into this, but in this case here, the y is 0, not the x. So x is going to be equal to 6 divided by 5. So that's a little bit over, so this point is going to be 6/5. And so my 2 points I'm going to use are here, 0, -3, so 0, -3, right there, and 6/5, 0, so it's going to be just somewhere right about there. Let's see here, somewhere close to there. Then I'm just going to connect the dots and go from there. And in this case here, I'm going to have to erase part of it, so you'll see what I mean in a second here. This, because it is that symbol there, less than, I have to have a dashed line. And so that's the reason why it's like that. And now I just am going to test 0, 0. Because 0, 0 is not a part of the line. And when I test 0, 0 into this equation, is 5 times 0 minus 2 times 0, so that's just 0. Is 0 less than 6? Yes, that's the case, so it's going to be everything on this side where that point is that I just tested. Quickly here, y greater than 1/2. In that case here, just every point is 1/2, so be like that. That's the line, y is equal to 1/2. And now I'm just going to test and see, well, what's 0, 0 again? Well, in this case here, I just need the 0 for the y. 0 is greater than 1/2. Is that true? No, 0 is not greater than 1/2. So in this case here, everything here, let me check that again. Oops, my mistake. Reverse that. I don't want to re-record the whole thing, but I graphed that wrong. See, I can make mistakes too, so let me fix this. I didn't graph 1/2. I graphed -1/2. This is graphing 1/2. It sort of threw me for a loop because 0, when I test 0 in for the 0, 0 point, I just plug in 0 for the y coordinate. And when I do that, that is not a true statement. And so everything under here is not true. So I have to, in this case here, I have to go ahead and everything above the line is true. And one more time here, don't forget, it's not a filled in line because instead it has this inequality symbol that is not equal to. It's just y is greater than 1/2. And that makes sense that it would be above there. Last one here, x is less than or equal to 1. So this time I will get it right, less than or equal to 1. So it's just going to be less than or equal to 1. That's going to be x is equal to 1. And now I'm just going to check that 0, 0 point out. 0. Is this true? 0 is less than 1. Yes, that's true. So that means everything on this side is going to be true. And all I did was I checked the 0, 0 point again. So hopefully this makes sense. And good luck in your studying. Thanks.